So here's the first example on the topic of frequency distributions. And it says the weight in kilograms of the 50 passengers on a small plane are given below. Represent the given data using a frequency distribution table. So we're given numbers here, all these numbers, 38, 42, 74, 78, tell us the weight of passengers on a certain small plane. We're given the data in this form, so we're just given numbers. And we're now asked to represent this data using a frequency distribution table. A frequency distribution table has two columns. One column, conventionally the one on the left, has the class intervals for the classes. So I'm going to write class, or let's just call it class intervals. So the class intervals for the various classes. And the second column will hold the frequencies of the data, or in this case the weights belonging to each class, the frequency. So that's essentially an outline for, or a template rather, for a frequency distribution table. Two columns, one for the class intervals, the other for the frequency of the data in each class. So scanning through the numbers I see here, I see that the smallest number is 38 and the largest number is 85. So what I'm going to do is define my own class intervals, and my class intervals need to be such that they cover all the numbers. So for the first class, I'm going to set the lower class limit as 30 and the upper class limit I'm going to call 39. For the next class, the lower class limit is going to be 40 and the upper class limit is going to be 49. So I'll just continue like this. Next class 50 to 59. The next class is going to have a class interval from 60 to 69. The next class is going to have a class interval from 70 to 79, and the next class is going to have a class interval from 80 to 89. So I've defined 1, 2, 3, 4, 5, 6 classes, and what you notice is that the smallest number 38 will fit into this class here, and the largest number 85 will fit into this class here. So I can essentially guarantee that all the numbers here will fall into a certain class. There are no decimal numbers, so I don't have to worry about class boundaries in this case. So what is the frequency of numbers in this class, or what's the frequency of this class? Let me put it that way. What's the frequency of this class? The first class, 30 to, with a class interval of 30 to 39. So for the first class, I'm going to use blue to circle the members of, well, the members. So we have to count. So let's see, 38 belongs to the class, and then no other number. So there's only one member of the first class, 38. So the next class has a class interval from 40 to 49. The members are 42, 45, 48, and 48. So we have 1, 2, 3, 4 members. So the frequency of the second class is 4. The next class is 50 to 59. 54 is a member. This is also a member. So I'm just going to cross out the members. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 members, so the frequency of the third class is 10. The next class is from 60 to 69, and its members are going to be crossed out. So it has 1, 2, 3, 4, 5, 6. Note that 60 is counted. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the frequency of this class is 15. The next class has a class interval from 70 to 79. So we need to find out the frequency of the class by counting its members. So here's 1, 70 is in the class. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. It has 19 members. For the final class, which has an interval from 80 to 89, the only member is this 85 here, so it just has one member. So we've determined the frequency of each of the classes. And just as a check, you need to know that because there were 50 passengers and we were given 50 weights, so the weight of every single passenger, the frequencies must add up to 50. That means the total frequency must be 50, the total number of values we were given. So let's add it up. 4 plus 1 is 5. 5 plus 10 is 15. 15 plus 15 is 30. 30 plus 19 is 49. And 49 plus 1 is 50. So that's always a good check to let you know if, well, let's put it this way. If you sum up all your frequencies and they don't add up to your expected total frequency, in this case, we expect the total frequency to be 50. If they don't add up, it definitely tells you you've missed something out. If it adds up, it doesn't necessarily tell you you're correct, but at least you can use this as a way to check if you made a mistake. So we're done here. We have a frequency distribution table, and as opposed to just raw data, let's see what we can interpret from just the table. Just by looking at the table, we can tell that the number of people that have a weight between 40 and 49 kilograms is 4 people. If we're just looking at the raw data, we would have to count. Obviously, we had to count them to produce the table. Imagine you were giving this information to someone else. They wouldn't have to count because they can already see the information here. So an airline can use this kind of information to determine the average weight of people on, let's say, this small plane, and then they can know how to design the plane to be able to carry a certain total weight of people, if you put it that way. So these things are important.